So this is kind of just a short review of linked lists. We've talked about linked lists before, but there's this programming assignment. So I just wanted to go over maybe just kind of review a little bit. I don't know if there's anything new here that you don't already know. So if you feel like you have a good understanding of linked lists, um, maybe this isn't necessary, but so I did post the code for linked lists. So for the assignment, I did post, what I did is this is the code I posted for the assignment right here. And so so you're just going to add methods to this code right here. And so and during one of the lectures I did talk about, I think this is maybe one of the first things I talked about was the add method. So remember that a linked list, I'm going to try and draw in here. So remember a linked list is just a series of node objects. So each node object, in this case, it's a two-way street. It's like a line, only you can get it, you can actually get in the line at the beginning or at the end. So the very first node is what's called the head node, and that's how, and then this previous one points to null. The one right before that, the very first node is null. And let's say this is the last node. The one right after the last node is null. And so if we're going to put a new node into a linked list, it can either go at the head or it can go after it can go at the very, you can go into a position like the first, like if you're in a line, you go right to the front of the line, or you can go to the end of the line. We actually number nodes just like array elements, just like 0, 1, 2, 3, so forth. And so this method actually adds at the very end of the line. Okay, so let's say so there's actually two cases whenever you're adding or deleting from a linked list. You have to consider the case that, well, so if we're adding that the link might actually, no one's in line, no one. I'm turning a node into a, no node is actually in line. And so the first thing you always do in any kind of add method, you're adding, you actually have to create a new node object. If you remember, what is that node, where does that come from? Remember, that's an inner class in, see if I can scroll up here. That's an inner class in the linked list method. So the user of a linked list, like just like array list, the linked list is, let's say someone in the main method created a linked list object. They don't have to know how data is being stored. All they know is that they want to store some data of type E, where E is just a class name. So if you have a little bit of visual time with the generic variable, the term that's inside the diamond operator, just pretend where we see E, you see string. And also that E extends comparable just means whatever class E that you pass, that you create with the linked list, has to implement the comparable. So when generics, when they say extends, it can also mean, I don't know why they do it that way, but this is called a bounded generic. E extends comparable. That means E either extends what's after the word extends or implements. In this case, whatever class E, you're going to create a linked list in the main method, and whatever you pass implements comparable. Okay, so but that's kind of for a different part of the code. Okay, so we're going to add, and again, so these nodes it's like this inner class that's defined right inside the code here, right? So every node stores an item, some data. That's the whole point. Nodes store data, and that's some kind of object that it's storing. And every object is going to be of type E, where E is like a class, it's like a variable for a class name. And every node can say what's the node directly after it and what's the node directly before it. And here's the constructor private node. That's how we actually create a node object. So when you're adding to a linked list, you're actually increasing the size. You're actually putting a new node into the linked list. So the first thing that we do there is go new node, and we actually create this node object. And then this is the node that we're actually going to add to the linked list. So there's actually two cases. So here's this case one. I'm drawing on the screen, students, so it's a little hard for me. And so case one, the list is empty, right? So you have this linked list, the size is empty, right? And so that's why you have that first case if size is 0. So if the head is null, okay, so the very first one's going to be the node, and also the last one. So this is the one case when the head and last refer to the exact same node, when there's exactly one node in the linked list. So if the head is null, So we've created this new node object, and let me see if I can scroll down a little bit. So you just create this new node object, and we're going to say the head is this node, and the last is this node. And so that's case one. And of course, then the very last thing we do is we increase size by 1. So we don't, we want to make sure size actually truly reflects the number of nodes in the linked list. Okay, but then there's the second case. Let's say size is greater than 0, so it could be 1 or more. So in this case, when you add a new node, the head and the last are going to be different. Okay, so let's say we have some kind of linked list here, and yeah, I'm going to add to this one right here. And we create this new node object, and we actually want it to go. Right now, this node object is not in the linked list. Let's just call it node. And so this would be case 2 right here. Okay, so now now your last would be here. Okay, so your last would be here. The one that in that drawing, that would be actually node number 2. And we want this new node to be last. So what we do here is we go, instead of last being the absolute last node in the linked list, we go last.next is assigned to node, or node is assigned to last.next. So the one after the current last is node. Okay, and then we say, oh, this new node that we create, we have to link it up. This new node, remember the new node that we created, and initially the previous and the next are null. But now what we're doing is we're updating node.previous and saying, oh, let's have it point to last. So this would actually go away, and then we'd actually point that to last. Okay, but the thing is, right now, the last is still this instance variable last that tells us where the very last node in the linked list is, still now points to the second one from the last. So we're going to update last, and so we're going to assign the address that was created when we allocated that node object to last. So this. Okay, so then we can do something similar, I think, then for add first. And I can't, let's see if I think that's a node that maybe it's a method that I wrote here. We have remove last. Yeah, add first. There actually is an add first. And there's a remove last, but you actually have to write a method called remove first. So one thing, students, is there's a bunch of methods already written. So make sure you know what methods are in there. Because sometimes, I do this, I write some of the code, and the students haven't actually reviewed the code that's already in there that maybe they could use or is similar to code that you already need. So one thing, as far as, so like one of the methods that you're going to have to do is, here's a display method. So I kind of like this method right here. So this tells us how do we advance in a linked list? And it's with that pointer is assigned pointer.next. So let me just kind of see if I can scroll here. Not doing a very great job here. And let's just insert a new page. So I'm almost done. Okay, so let's just look at this. So again, let's say we have this linked list. It's a two-way street. And we want to iterate. We want to actually print everything that's in all the data that's inside the nodes. Okay, so we're gonna display from first to last, and remember, last.next is null. Okay, so we start the see if I can just move this over a little bit. And so that's not being very cooperative, is it? Okay, let's just see here. Just use my cursor. Let's see if I can move this window over just a little bit. Okay, so yeah, so we have this public void display. So the public is kind of cut off a little bit. Okay, so so the first thing we do is we declare some variable. We're declaring a new variable, local variable called node, but we're actually not allocating memory for pointer. We're assigning it the very first one. So now the pointer, so we start the pointer right here. We start at the very first node. And then what does it say? Well, pointer's not null. Well, if there's a node, if size is 1, then is 1 or greater, it's not going to be null. The only time it's initially null was when size is 0. And then we print out the current item. And it's this thing right here. Pointer is assigned pointer.next. That will just advance us to the next node. So that's one of the key things about linked list. So pointer, how do we advance to the next node? It's kind of like I++ in the array world. This is advanced. So pointer, like here, if this is pointer is the head, this one would be pointer dot next, right? Pointer dot next is the address of the node after head. And what we'd be saying is the address of the node after head is now assigned to pointer. So then if we executed this one statement, pointer would now be at node number 1. And that's how we advance through a linked list. And so definitely make sure you review this, because one of the methods you have to write is to do this display in reverse. We go from last to head. And I think if you just use this, you could actually just make a short modification, small modification to display, and you'd have that method. You really just changing 2 lines. Now, the only other thing I want to say is to, as far as I actually did, put this file up for you to test your code, but I would encourage you to just kind of write your own methods here to do some testing. Let's say you do this method that displays in reverse. So just create a linked list, add a few nodes to it, and then just call the display in reverse method to see if it actually displays your code. So here, so something like, yeah, so you could actually easily just, okay, so you have this linked list, and yes, you could just go list.add, let's say like cat, list.add, dog, maybe just one more, then list.add, like book. And then now you could just call your display in reverse method to see if it displays, the dot, and then just invoke the method that displays in reverse. And you'll see it. So you actually don't have to use, so I have to have this test, this code to test all the methods, but it's really easy to write your own, and I would encourage you to do that. So one other thing, students, just again, is let me just look at the code right here. So So the one thing is, so you're going to have to write like a contains all method. So you'd probably want to use that contains method right there. And there's no need to actually write your own contains method, because I've already written that. So the contains all would, I know that's why I implemented it. I called the contains all calls the contains method. So just make sure you know what methods are already in the code, and it might make it easier for you to write the code. Okay, that's all for now. You're always welcome to write questions or ask me during the lecture. And yeah, I'm trying to figure out how to stop the recording.